Hello friends, in this video we are going to discuss the previous year GATE question number 103. This question is from GATE 2018 examination. Let us read the question. A DC to DC converter shown in the figure is charging a battery bank B2 whose voltage is constant at 150 volt, right? So this is the B2 they have given, and it is like a V0, right? V0 is equal to 150 volt. B1 is another battery whose voltage is constant at 50 volt. Okay, so B1 is like it is equal to Vs, that is the supply voltage, which is 50 volt. The value of the inductor L is 5 millihenry. So L value is given, and the ideal switch S is operated with a switching frequency of 5 kilohertz with a duty ratio of 0.4. Once the circuit has attained a steady state and assuming the diode D to be ideal, the power transferred from B1 to B2, right? So power transferred from B1 to B2 means what? We need to find the source current, okay? Source current into source voltage, okay? Source current into source voltage. So in this way we can find. So here let us first note the given data. The V0 is equal to 150 volt, right? Next, the supply voltage Vs is equal to 50 volt. Next, the inductor L is equal to 5 into 10 to the power minus 3 Henry. Next, switching frequency is equal to 5 into 10 to the power 3 Hertz. This is the switching frequency. Duty cycle D is equal to 0.4. Okay. So now if you check, this is the boost converter. Okay. This is the boost converter, and for the boost converter, we are having the expression for continuous conduction V0. Okay. So for boost converter, this is the boost converter. So for boost converter, if you check, we are having the expression for V0, which is equal to 1 upon 1 minus D into Vs. Okay, so if you check, V0 is equal to 1 upon 1 minus D into Vs. Okay, so V0 is a 150, and for this duty cycle, if you check whether it is equal to the 150 or not, we are going to discuss. Okay, for D is equal to 0.4, it is given D is equal to 0.4. V0 is equal to 1 upon 1 minus 0.4 into, it is a Vs, that is a 50. So it will be equal to like 50 divided by 0.6. So it is 83.33, 83.33, which is not equal to 150, which is not equal to 150. Are you getting the point? Okay. So here can we say that yes, as this expression is for continuous conduction, and for continuous conduction or continuous IL, okay, and for this expression and given duty cycle, right, where whatever the output is specified, this is not matching. Okay, so can we say that this is nothing but the discontinuous conduction? Okay, so therefore for the from the given data, from given data, the IL or conduction, the conduction should be discontinuous. Conduction should be discontinuous, right? Discontinuous, right? Conduction should be discontinuous. Now, for discontinuous conduction, yes, we are having the V0, right? V0 is equal to, for discontinuous conduction, V0 is equal to beta upon beta minus D. Okay, we are having beta upon beta minus duty cycle D into Vs. This is the expression, right? Now let us put it is a 150 volt. What is the beta? We need to find upon beta minus 0.4 into Vs. What is the Vs? It is a 50 volt. So from this we can find beta. Okay, so from this, right, beta can be calculated as, therefore, yes, 150 into beta minus 150 into 0.4, that is equal to 60, is equal to 50 into beta, right? So from this, yes, we can write it as a beta is equal to 60 upon 100. Okay, 150 beta minus 50 beta, so it is 100, so it is equal to 0.6. Okay, so beta is equal to 0.6. Okay, beta is equal to 0.6. The meaning is, yes, inductor stores the energy from 0 to dt, and from dt to beta t inductor will release the energy. Okay, so if you draw the waveform of il, right, it will be like this il waveform, because the conduction is discontinuous, so therefore il waveform it will be like this. This is the time t 0, here it is a dt, and here it is a beta t, here it is a t. Okay, so il from 0 to dt, inductor go on storing the energy, inductor go on storing the energy. After that inductor releases the energy, and again it will be 0 now. Next, after t again inductor starts storing the energy. So this is nothing but Imax. Okay, now roughly if we draw, yes, the waveform of il, yes, it is like a average will be Imax by 2. Okay, or it will be like, we can write this as, this is like a delta il. Okay, this is like a delta il. Okay, and what is the average? Average will be delta il by 2, right? Il average is nothing but delta il by 2. Okay, so it will be having the il average, so it will be like this, from here to here is il average, after that it is a 0. Okay, and after that again the same, it will be il average, it will be il average, which is equal to what? Delta il by 2. Okay, now, right, or from this can be drawn like this only. Okay, next, so now we can find, so let us write it as only delta il by 2. Okay, that will be better. So let us write it as delta il by 2, that is nothing but the Imax by 2. Okay, now if you check the circuit during t on, during t on, okay, can we apply the kvl? Yes, so during t on we can draw the circuit and we can apply the kvl. During t on, during t is equal to 0 to dt, that is a t on. Okay, yes, the circuit will be like this. Here we are having the supply voltage is a 50 volt inductor, and here it is a switch. Okay, so if you check, the switch is acting as a closed, inductor value is given, this is equal to 50 volt, right? And what about the L value? L is equal to 5 millihenry, 5 millihenry, and the current given is a IL. Now can we apply KVL to this loop? Yes, it is a plus 50 minus 5 into 10 to the power minus 3 into DIL by dt is equal to 0. Okay, now from this we can write, yes, what is the change in the inductor current during t on? It is Imax minus 0, that is Imax, that is nothing but the delta IL. Okay, so we can write it as 50 is equal to 5 into 10 to the power minus 3 into delta IL divided by, it is a dt time, time is a dt. Okay, that is a t on. So therefore we can write delta IL is equal to 50 upon 5 into 10 to the power minus 3 into dt. What is the dt? D is, it is given 0.4, and t we can find. So from this delta IL is equal to 50 upon 5 into 10 to the power minus 3 into d, that is a 0.4 into t, right? What is the t? It is a 1 by frequency. What is the f? It is a 5 into 10 to the power 3, 3 into 1 upon 5 into 10 to the power 3. Okay, so now from this we can write it as equal to minus 3 plus 3 will get cancelled out. Okay, so therefore it is 50 into 0.4 divided by 5 into 5. Okay, so it is equal to, divided by 20, so 0.8, delta IL is equal to 0.8 ampere, right? The delta IL we are having. Okay, now can we find the IL average? Yes, IL average, right? IL average, if you check the IL waveform, we can write IL average. Okay, so this is a linearly increasing and it is a linearly decreasing. Okay, so we can write it as a 1 by t integration from 0 to beta t. It is a delta IL by 2 into dt. Okay, so IL average, therefore IL average is equal to IL average is equal to 1 by t integration from 0 to beta t. Okay, is a delta IL by 2 into dt. Okay, so is equal to 1 by t. Let us take it as a delta IL by 2 outside. So delta IL by 2t into here it is like a beta t will be having. T will get cancelled. Okay, so it is equal to delta IL, that is a 0.8 divided by 2 into beta. What is the beta? Beta is equal to 0.6. Beta is equal to 0.6. So therefore IL average is equal to zero point 0.8 into 0.6 divided by 2. So it is a 0.24. 0.24 ampere. This is the IL average, right? So therefore power transferred from B1 to B2. You can write therefore power transferred, okay, from B1 to B2 is equal to Vs into IL average. IL average nothing but the source current, average value of source current. What is the Vs? Vs is given, it is a 50 volt. It is a 50 into 0.24. Right? 50 into 0.20. 50 into 0.4. It is equal to 12. Right? It is equal to 12 watt. So final answer is 12 watt. Right? So this is about the question number 103. Okay, power transfer from B1 to B2. It is equal to 12 watt. Right? So here it should be 12. In the next video, we are going to discuss the previous year GATE question number 104. Thank you.